Okay. So we're going to do the first derivative test. Okay. So if you remember, if the derivative is positive, for every value in, let's say, some interval AB, then we know that f of x is increasing in that interval. Because if it has a positive slope, it's increasing, especially if it has a positive slope everywhere. The opposite is true. If f prime of x is less than 0 for every value of x, why don't I put all and not every? Every just sounds better. For every x in that interval, then we know that the function is decreasing. Oh, went up a little too far. And we know if the slope is equal to 0, then the function is a constant. So f prime of x equals 0. For every x in the interval, then that means that f of x is a constant. Okay. So using what we know about that, if they're saying that if you go from a positive slope to a negative slope, that means your f prime of c is going to be the maximum. Okay, so let's write that out. So when f prime of x changes from positive to negative, then f prime of c equals 0 is a local maximum. Okay, so if we had a graph, let's say here, clean that up some, to here. Now that's not saying this graph doesn't keep on going and going and going and going, but we're just kind of focusing between this A and B. Okay, so it's saying that if this slope is positive, and then all of a sudden it changes to negative, then this point here is your maximum, because that's your 0 slope. Let's bring that down a little bit. Okay. So that's your f prime of c is equal to 0. So that would be your maximum. That's it. Doesn't necessarily mean it's your absolute maximum, because like I said, the graph could go higher and lower in other places. But just between that interval, it's your local maximum between there. Okay. Now, if it changes from negative to positive, then you know where f prime of 0 is your minimum. So it's a local minimum. Okay, so once again, let's say we have our, between our A and B, like I said, for all we know, the graph could keep on going and going and going and going, but we're just focusing between there. Say your slope here is negative, and your slope on this side is positive. That means when you do find your f prime of c is equal to 0, it's going to be your minimum. All right. Does that make sense? All right. Any questions on this so far? All right. Okay, so let's do one quick example. Okay, so what if we wanted to identify the absolute minimum for g of x equals negative 2x squared minus x plus 1 over negative 2 to 4, or over the interval. Okay. So the first thing you want to do is evaluate the endpoints. Which means you want to find g of negative 2 and g of 4. So g of negative 2 is equal to negative 2 times negative 2 squared minus negative 2 plus 1. Negative 2 squared is 4 times negative 4. Negative 2 is negative 8 plus 2 is negative 6 plus 5. So we know that g of negative 2 is 5. Oh, negative 5, sorry about that. Okay, and g of 4 is equal to negative 2 times 4 squared minus 4 plus 1. So 4 times 4 is 16. So you have negative 32. Negative 36 plus 1 is negative 35. So negative 35. Okay, so we evaluated our endpoints. Okay, now your second step is you want to find every value that would make your slope equal to 0. So we call those the critical points. So find all critical points. Which is just where g prime of c equals 0. Okay, so first we have to find g prime of c. So g of c is equal to negative 2c squared minus c plus 1. So our g prime of c is equal to negative 4c minus 1. So we have to find out where that equals 0. Okay, so negative 4c minus 1 equals 0. If we add 1 to both sides, divide by negative 4, we know that c is equal to negative 1/4. Okay, so we have our g of negative 2, our g of 4, and we know the c is equal to negative 1/4. So our third step is we're going to find g of c. It means we're just going to plug that into our original equation. and compare all g of x values. Okay, so that means our g of negative 1/4 is going to equal negative 2 times negative 1/4 squared minus 1/4 plus 1. Okay, so if we have negative 1/4 squared, that'd be positive 1/16.
It would be minus negative 1.
Oh, negative, thank you. So you have negative 1/16. Negative 1/16 times negative 2 is negative positive 2/16, which gives us 1/8.
Square would make it positive 1/16, right?
Yep, positive 1/16, but then that negative 2 would make it negative 2/16, which is negative 1/8. Plus 1/4, which we can make that 2/8. Plus 1, we can make that 8/8. Which would make that 10 minus 1, 9/8. Okay, so that means we have g of negative 2 is negative 5. G of 4 is negative 35. And g of negative 1/4 is 9/8. That's our smallest y value, so that's going to be our absolute minimum. Now, if you were looking for the absolute maximum, you do the exact same steps, but then when you get to this part, you're going to look for the largest y value.
So in this case, our absolute maximum is 9x.
Yep, if they were looking for the absolute maximum, it would be 9x. Yeah. I mean, not 9x, 9/8. I don't know why I said x. All right. Any questions on that one? All right, so that is actually it for today. You're welcome. Have a good one. Sure.
So can I use the board as I have natural log of 166 sine of x, tangent of x, right? Do that, right?
Yep.
Okay, so then
Will you have a chance to upload the test grades before Monday?
Yep, I should be able to.
Okay.
You can just throw mine in the garbage.
They weren't up today. I didn't check.
I think I corrected most of them. I think I still like a few days on.
Yeah, I got you. All right, thank you.
No problem.
this is also true, right?
Yep.
Okay. And then there's enough I'm doing that, then we have prime of x, we know f of x, right? If I were to, or I should say I was integrating, differentiate somewhere. Or am I doing this wrong?
That's only if this is your
Yeah, that's what I was trying to say, sorry.
Oh, okay.
It's just, note that up there.
Yep, so just the f prime of x is just the derivative of each one of those terms. So
Yeah.
this you would.
I wouldn't need that. So I don't need that when I'm integrating, doing logarithm, differential, whatever they're called.
For some you would, but for this one you don't. But for this one you would. So you would have, yep, see, this one you can actually make that 6. Oh, no, that's right. Got a derivative first. Yeah, this one. Yep, so this guy, prime of x. Actually, that's right. Your prime would equal, actually bring that to the front. That would be 6 natural log of x. Would be 6 times over x minus natural log of b to the x. Those two cancel, so you get just x. Minus natural log of cosine of x. Natural log of u is u prime over u, so that would be negative sine over sine, so positive, negative sine over cosine, so it would be positive tangent x.
Okay. So when I did this problem
Mhm.
online, I got a different answer. And this is the answer I got,
Mhm.
but they didn't simplify it like I just did. So, you
To be
know-
honest, the first thing I would have done was make that natural log of x6 tangent x minus natural log of e to the x sine of x, and then make that natural log of x to the 6th plus natural log of tangent x minus natural log b to the x minus natural log sine of x. That would have been my first
Yeah.
response, but that one looks like it should have worked anyway. Like I always say, if you ask 20 people, you get 15 different methods. So
Yeah.
that would be 6. This is just our function. Okay, so if we bring that 6 down, we can do that. Okay, so that should still give us the same thing if we differentiate it. 6 over x plus natural log of tangents, that's sine over cosine, that's u prime over u. Tangent is,
So that's 1 over tangent over secant squared, right?
yep, 1 over tangent secant squared. So actually, you could, it would have been easier to do it that way. You're not dealing with the tangent, so secant squared over tangent, which secant is just 1 over cosine, so that would be just sine over cosine squared, which makes it really, really complicated. Minus, those two cancel out. Natural log of sine, that's u prime over u, so that would be minus derivative of sine is cosine. Sine of x. So that one, and actually, if you divide both of these by cosine, you'll just get so that would give you 1, and that would give you 1 over tangent, which is just tangent, so that would actually give you 6 over x, and I'm pretty sure that can be simplified too. So that's 1 over cosine times 1 over cosine squared, so that should actually be 1 over cosine. That one, yep, so this one gives you cotangent. Yep, 1 over tangent. Yep, tangent. Plus, and this one I have to simplify later because I actually got to run. So secant squared. Oop, cosine over sine. So it should just be 1 over sine times cosine, which really, unless you start to combine like terms, which it looks like that's what happened there. So really, once you combine those two, you should end up with tangent x.
Okay. So online it ended with this, and then this was a tangent.
Mhm.
So that's what I did online. So I was really frustrated because I'm like, this is not wrong. It's different. So,
I know, and it seems like they're just picky about how it's presented.
I'm never doing that.
And that was the first thing I did, even though it's longer. Yours was actually a lot quicker.
Alright.
But that would have been my first
What was
jump.
the- In terms of signing the code signs?
I know. I need to follow my own advice.
Sorry about
That's
that.
I'm not actually gonna be here next week. I ended up, I have to attend a wedding. That's a destination. So, yeah.
All right. Like I said, everything will be.
Yeah, I mean,
this is
it's-
still recording.